Hey, really nice to be here today. Yesterday came from San Francisco, all the way from San Francisco, and it's really different city here compared to San Francisco, and very excited to be here. So we're gonna talk about the observability, like what happening in observability, how actually changing the market, and what gonna be the future trend. So before we talk about observability, I'll give you a little bit background about myself. So my name is Laduram, and I'm founder and CEO at Middleware. Before Middleware, I was running a company called Acquire, and I ran that company for 6 years. I took that company just by myself to 200 people and raised like 60 million in venture funding. So around 2017 and 18, so we were building like V2 product for our company. And when we were building V2 product, we were looking for observability product specifically for cloud native and microservices. And when we were looking product, there wasn't any great solution in the market. So what we did, we built a small version of observability by ourselves. That was like a backbone of observability, like what we're doing here today. So before we talk about the future trend and evolutions of the observability, we understand a little bit about the backgrounds of the observability, like what happened in last few years about the observability. So we were running like on-premise data centers, and when we were running on-prem data centers, the core observability providers company was SolarWinds, BMC, and CA Technology. That's what we were using. So that was from Gen 1 observability from 1998 to 2008. But this market, again, started changing around 2008. So what happened around 2008, like we all start moving to the cloud. When we were start moving to the cloud, AWS for the world came, Azure started launching the new observability providers. So Azure started launching the cloud providings. Almost like 7 to 10 company launched around 2008 to 2012, and mostly was focusing on monolith and cloud observability and cloud monitorings. And we can see some of these companies' name, and they've become like a really huge company there. But this market again started changing around 2018. So what actually happened around 2018 is Kubernetes launched around 2014, did not get adoptions around until like 2017, 2018. When Kubernetes started getting adoptions around 2018, people just start moving to microservices. Uber was the first company start building like 3,400 microservices, and they say like we completely microservice based like architectures. We, and my company Acquire, we face the problems and we build our own observability providers. And Uber also like face the same problems. So what they build, they just come and they build like M3DB, and M3DB like was the first cloud native observability inside the Ubers. And then few engineers came out and they built a company called Chronosphere. And that was like how the observability was changing. So we saying like how the observability is changing in last few years, we seeing like quite a few like new companies are coming in observability space, and they just changing. So what actually happening is cloud native produce is like three biggest like problems that we're facing in observability space now. Cloud native actually produce way too more data than ever before, like monolith services and all of those things we running before. If we see like 99% of the data that is produced was in last 10 years. So there's too much data producing. If we send all those data to observability stacks, it's gonna be huge in the cost. So like egress cost gonna be huge, and also like these observability company will never say like, hey, do not send all the data, send all the data, they can handle it. But then its cost is go exponentially higher there. And if we send all the data, 70% of those data is like not useful. If we send like info log, event logs, and most of the time those data is like kind of not useful. So like we probably need to filter some data out. And last but not least is evolving the priority in observability after cloud native is launched in the market. So what happened is like before we were focusing on melt data like metrics, event, log, and trace. But recently, after cloud natives and Kubernetes launch, we do not care about metrics or melt data that much compared to the SELT data. So SELT is like latency, traffic, error, and saturations. And compared to like, if you're running a pod in Kubernetes, your pod hit like 90% of the memory, it will automatically deploy the new pod. So you normally don't care about that data now. You care about like what latency of your applications and what traffic is hitting there, how many error is producing there, and what saturation is going on. You guys must be thinking like, oh, there's too many problems. What are the solutions? Like, can you come up with the solutions? We're like, middleware could be solution. But like, I'm not saying like middleware could be solution, but like before you go and look at the solutions for the observability stack or your current stack that what you guys using and you're trying to move somewhere else to look at the observability, you should be asking few questions to those companies if you're trying to move and you're trying to go in the market there. You should be asking like, can you collect what you need? Rather than sending all the data to cloud and paying huge cost on egress, you should be able to ask like, hey, we collect 300 points on a metrics on Kubernetes stacks. Do I need every single point? You should be able to have those data inside the browsers so you can switch on and off and you can track like, do you actually need or you don't need it? If you don't need it, you can just switch off. But then the switch off, it should be on an agent level, not as your engineer go and switch off the data from the agent level. That is take too much time for your engineers to switch off any metrics is sending to the observability stacks. So make sure you switch off on the agent level in the machine so you don't pay the egress cost there. Anything you're going to be paid, you start collecting data, sending it, you're still paying the egress cost. Some of you must be thinking is like, we actually need all the data and how we can run it. So if you need all the data, you should be thinking about the private cloud. And private cloud is like you deploy inside your own AWS infrastructures, so you don't send data outside your infrastructures. Give you examples, we have one of the largest customer based out of India. They're sending roughly 700 terabyte observability data outside their infra to one of our competitors and paying 1.2 million egress cost. They even didn't realize this one before we talked to them. And we say like, you paying over 1.2 million egress cost is just sending observability data outside your cloud. If you do not send these data and keep all within your cloud, then you can save this whole money. And that was because before they was counting that cost, it was not, it's not as a observability cost, but it was the cloud cost. But you can save so much money to deploy in a private cloud. One more is like really trending topics is happening in the market is like integrating your observability data with your business data. So some of you guys must be like a banking customer, e-commerce customer, like running banking industry or e-commerce or any of those things. Sending your business metrics to the observability and integrating together can solve a lot of problems. So like, let's say one morning, you just wake up and one of your DevOps engineers go and look at your whole Kubernetes stack and it's just pumping CPU by 70, 80%. That engineer even don't know like what actually happening inside your infrastructures. If you're sending your business metrics, you say like your banking customer, you get 1,000 transactions every single day, and that day you get like 10,000 transactions. So that means the engineer know like, oh, we got like a huge volume in our business metrics. So correlating between business metrics and correlating between observability metrics, it can give a really better efficiency in the operations team, your executive teams, and in your business team. Plus, it solves a lot of problems to your engineers and DevOps teams as well. Other things is unifying all the observability stacks. A lot of companies actually send a log somewhere else, metrics somewhere else, traces somewhere else. So unifying is really, really hard. If we don't correlate between metrics, log, trace, event, RUM, all of that things at one place, then it gets really challenging there. And what I mean unifying is you send your browser stack from RUM, like real-time user monitoring, to your front end, whatever you're running in like React or Angular or Vue.js or any of those things, and correlating from your front end to your back end running in Node or Python or Java or any of the things you're running in the back end to your DB. All span at literally in one timeline can solve a lot of problem in the observability stacks. OTel is big in the market now. A lot of people are actually moving to the OTel standards, and like if you go to like Gen 2 providers, like all the Gen 2 companies that we discussed in the previous slide, they're always gonna say like, hey, collect all the metrics, send us all the metrics. If you start collecting all the custom metrics, then you just start configuring all their APIs and start building their APIs and building on the top of their APIs and start sending all the metrics to using their agent. And if you're using their agent and start building whole ecosystem around that, that is just become really complex. If you think about you want to change the provider one day because his cost goes really high, or like any other reason, company got acquired or PE firm got acquired, they increase the price, then you can't even move anywhere else. If you want to move anywhere else, the biggest challenge is like you need to rebuild everything what you built for like last decade or something. So you should be asking all those companies like, hey, do you support OTel? And if you support OTel, can we start collecting data, sending OTel, and then you can switch provider at any point of the time there as well. Last but not least, predictive AI is big. There is a lot of companies in, so I'm from San Francisco, so AI is a huge thing there. Everybody's talk about here, the AI in San Francisco. There's a few companies start doing AI in observability, and you should be asking like, it's not AI as a chatbot. So you can say like, hey, you can ask the question to chatbot. You can go and look at your dashboard and like what happened inside the data. So chatbot, it doesn't solve the problems. What is solve the problem? Can your observability stack, your agent, have AI inside the infrastructure is running there? So that can detect like what actually happening, what kind of anomaly is producing there, and then how to solve those anomalies. False positive is one of the biggest challenge in observability stack in the market right now, where you get like 100 alert every single day. Out of 100 alerts, maybe like 40, 50 alerts is just useful that you just need to go and you look at it and you say like, oh, this is like actually useful alert that you need to check it out. The predictive AI can help. A lot of false alert is producing from there as well. My name is Laduram. This is my QR code. You can scan and you can connect with me on LinkedIn. And if you have any questions, I'd love to answer it.
Hi, good afternoon.
Hey, there we go.
My name is Abhilash. I am from Nakhil. Right now, actually, we are at the stage of evaluating an observability solution for our environment. So I was just looking at the Magic Quadrant from Gartner. There are different niche players, for example, New Relic, Dynatrace, AppDynamics, even IBM has some offerings. So how does middleware differ from all these solutions actually? Because as a customer, what would be the criteria that I allow you to just go for middleware?
Yeah, thank you. We are actually not in the Magic Quadrant yet. I started the company last year. We actually launched the product earlier this year, so we are not there yet. Probably gonna get there at some point. So the difference is like really good question. First difference, if we say about the product wise, we are heavily focused on AI. Our agent that have an AI agent inside the infrastructures like in Kubernetes or Ubuntu or any of those things, and then we actually look at like what we sending to the notifications to the users. So like we look at that before we send it. Second is pricings. We are almost like 60 to 70% cost efficient in the pricings. Third, we can say like we are on-prem, so you don't pay egress cost. That's what we talk about, like one of our customer was paying like 1.2 million just on egress cost. So you can run our whole platform within your own cloud, so you don't pay. And then last but not least, we completely OTel based. So you build your own infra and then running through the hotel as well.
Hi, my name is Nacho. I'm from Bank Saudi Franci. I just wanted to understand the difference between the observability with AI capabilities versus the AI ops. So in the past, I was working for IBM, and then IBM had this AI ops product, and also there are many other AI ops products in the market. So how observability product with AI capabilities differ from AI ops?
That's great questions. So AI ops is different than observability. So observability is like a new word. It just started happening in the market from last like maybe 3-4 years. It's just when it started changing in the cloud natives, and there was a bunch of data observability company come, and there's a bunch of like actual observability start coming. We actually don't do AI ops. AI ops is a little bit different. We are actually the observability that you can collect metrics, log and traces and events, RAM and synthetics, all of that part in that side. AI ops is like you look at more into your model trainings, how efficient your model is, how you train it, like, and how it's running, how you deploy it. All of that was in AI ops. Right now we don't cover that part, but we just covered the rest of the part. About the AI agent that we discussed there. So AI agent is like when we collect any data, our agent collect any data, we actually do not send all the data to AI agent because that's going to be really expensive to train the data to AI and get outcome from it. We send only those data that's produce some errors, produce some like latencies, or produce some error trace from the log to the traces to the events to the metrics to any of those things, and then we just only send those data to learn more about it from your infrastructures.
My question is, what's your take on bringing observability to legacy applications?
Yeah, really good questions. Latency is really huge topic in observability stack recently. So like Amazon did one of the testing few years ago. If their website is slow for 1 second, they lose like over hundreds of million in revenue. Legacy application. Oh, okay, all right. I was thinking about latency. So legacy applications. Still there is a monolith and a lot of legacy applications. So we have customers like JPX, Tokyo Stock Exchange, is everything running monolith applications. Because they're also done with it, so they're also converting their whole legacy applications to the Kubernetes now. Because Kubernetes is more agile, is more scalable, is more secure, and you can like scale to horizontal and verticals and all of different sizes. So a lot more companies actually moving from the legacy to the new stack, but still there is a lot of companies are still running in legacy, and that's what we see like first generation, like people still use SolarWind and BMC and C technology there. Probably not, yes, that's correct. But then people are trying to do it. It might take like a long time to completely move away from the legacy.
Okay.
Thank you for that.
Myself, Aravindan. Actually, we are using application insight as like part of the code. In the developer itself, they're integrating as the package. Is a developer friendly. They can give more insight about that. So how the middleware going to take over this?
So we actually don't do the code part, to be honest. We just mostly do on infra and applications part after you deployed it to your infra. And then once you deploy it, it's how your infra is running, how Kubernetes is running, like how many pods are running, is new pod, your pod crash or like not crash. When you like actually like sending a code and like CI/CD pipeline and monitoring that we're not covering, to be honest. We're covering most onto the infra and applications, mostly like traces and APM sites.
Okay. Mostly it's the agent based, right?
That's correct, yes.
Hi, this is Jennifer from Landmark Group. So I have a question around these spans. Like there are limitations in the number of spans at the time in other observability tools. So in middleware, do we have such limitations in tracing all these spans, or how good it is simultaneously how much spans it can count it and produce the data?
Limitation in terms of like sending a span, there is no limitations. There are always going to be limitations about how many span you get, and then how those correlated. And that will be depend, it's just like how your applications run is and how your application sending the span. Sometimes they're going to be like you look at the span and you're going to be like a 3 span, and sometimes you look at like 100. But that's like how you actually configure OTel. OTel is so much more robust than any other platform that I can see, any other agent I can see in the market. But it's just all about like how you collect the data, how you send the data. OTel technically collect all the span automatically. So you probably don't need to manually configure it and go inside your every function and just write like, hey, can you send this data or can you do that? So it's technically automatically collected, but there are going to be always going to be limitations there.
Right,
Because
we're
I
gonna
have been
head in.
facing this issue of dropping out spans because of reaching the maximum limit. That's where my question is on. And one more question on the service map
I'm going to
standpoint.
interrupt you there because we've got to go for a break. But Laduram will be around, and I'm loving this enthusiasm. So thank you so much for the question. He'll be here.
I'll be here. I'm not going
you
anywhere.
You can grab hold of him. But thank you so much for your questions, and thank you everyone. You certainly hit a rich vein there. Thank you, Laduram. And a big round of applause, like you said, all the way from LA. And don't worry, he will.